of class 9, presenting a very interesting topic about quantum is potentials and charges. So before we move on to our main topic, we have to see a very brief classification done by English physicist Paul Davies. He classified 19th century as mechanical age, 20th century as information age or IT age, and 21st century as quantum age. Then what is quantum? So basically quantum is the smallest bit of anything such as protons, neutrons, electrons, photons, etc. The term quantum was coined by Max Planck in 19. So to understand it in a better way, we have to learn some basic differences between classical physics and quantum physics. Firstly, classical physics is deterministic. It means the classical physics is predictable. Suppose we are taking a ball and we are leaving it from a height, then we can predict that at what velocity it will fall on the ground. But in quantum physics, phenomena are not predictable. There is no 100% certainty that it can happen. Secondly, it works on macro level. It means classical physics works on these tables, these flow, humans, etc. Or quantum physics act on micro level, including all these things. It also works on micro level. Like as I said earlier, protons, electrons, neutrons. And one of the major differences is that in classical physics, the atoms behave differently. The particles behave like particles, and the waves behave like waves. But in quantum physics, in classical physics, atoms
macro level classical physics के लेवल हम लोग macro level की macro level जो है एटम level जिनसे macro level जिनसे एटम level इसको है ना
अंदर है सर आप ये अलग चीज़ में मैटर होते हैं ना
हाँ मैटर एटम level हेलो मैटर
so the metals behave differently. The particles behave like particles, the waves behave like waves. But in quantum physics, they act like both. So just suppose we take a photon of light, then when it is moving or propagating, it will behave like a wave. But when it is interacting with something, then it will behave like a particle. Then what is quantum age? So basically, quantum age is the current emerging technological era which is governed by the principles of quantum mechanics. And to run the quantum mechanics, we need special computers, which are the quantum computers, which have QPU as their processors. So, which are based on qubits, which range from 0 to 1. Just like in CPUs, 0 and 1 are bits, but here all the numbers between all the complex numbers between 0 to 1 at qubits.
तो ये एटम जो कोर्स जो करा चाहलो एटम रे कोई तो का होता है कोरो तापर से हम क्वेश्चन देना जन एटम बोल मेट्रो जन बोल चेंज हो जाए तो एटम हिसाब से तो का करा चाहलो कोरो
पहले सर ये कह दीजिए हमार सपोज ई टेबल नंबर
नहीं हटा सर एटम हिसाब कोई तो पॉइंट जो देखो तो आपके
नेटवर्क सर कोई लो एटम सर
तो दूसरा क्लासिकल फिजिक्स में एटम का हमें के लेवल चिंता करना हम बुझ लो नहीं
मैक्रो लेवल
हां
और मैक्रो लेवल पे होते हमें बेसिक
तो एटम का काम बुझ लो नहीं एटम क्लासिकल फिजिक्स से एटम जो एटम में नाम
এটা কি আমাদের ঠিক আমার পার্টিকেলস ও ওয়েভ যেটা আলাদা আলাদা হিসাবে বিহেভিয়ার দেখাচ্ছে মানে এটি দুই প্রপার্টিজ
বলে ক্লাসিক্যাল ফিজিক্স এটম না তিন ভাবে বের করব
ক্লাসিক্যাল ফিজিক্স
হিসাব কেন ভাবে বের করব
যদি পার্টিকেল মানে পার্টিকেল যদি ওয়েভ ওয়েভ
এটম না কাউন্ট করব ওয়েভ না হবে পার্টিকেল হবে ক্লাসিক্যাল ফিজিক্স হিসাব
পার্টিকেল
हां কিন্তু এই হিসাবে ম্যাডাম না করে আইডার দুই রাখবে हां हां
then let us jump onto the potentials of quantum mechanics. So the first potential superfast computing, as this use qubits as bits, so they are much more faster than the classical computers. And also additionally these provide complex problem solving. classical computers can't do. Then secondly, it enhances the security in communication. The quantum cryptography is much more better than the encryption and decryption methods in classical mechanics. And thirdly, the AI which are made by use of quantum mechanics have greater thinking capacity. They have zero IQ, but they are better than the classical AI. Then there comes the finance domain, which means that we can analyze the risk in stock market, we can detect frauds in banks, etc. These all are the potential of quantum. But just like anything in universe, these also have some demerits, and those are here. So, firstly, quantum mechanics are not at all cost effective. They need, for their infrastructure, they need very huge amount of money. As the winning point is zero degree. Secondly, the complexity of knowledge in quantum mechanics is makes the people made the scientists more than 200 years just to learn this basic, and we are still learning about the quantum mechanics. Thirdly, there is a digital security gap. Suppose if we take an encrypted data of classical computer and encrypted data of quantum computer, then this is more better than this. But when we are transitioning from classical to quantum, the quantum may have the rich data and they take the data and may leak, which may harm the agencies. Then also huge energy consumption, and they are frequently nearly 0 degree Celsius, so they require very much energy consumption. And then also social disruption, like the process of jobs, or just like invention of Facebook, WhatsApp, reduce the social interaction. It may cause some like that. But everything in universe has some demerits. If we tackle them in a good way, then it will be an advantage for us. And so the future of quantum mechanics depends on how we manage its concerns. And if we manage it in a good way, if we manage it for human development, then it will act in our advantage. If we use it in wars, in harming other people, then it will destroy the world. It's that much capacity. So at last, I would like to say that this is the era